Today is 2025, 2nd of May. What I'm going to do is NLP midterm review. So, okay, first, uh, tokenization is not always reversible if 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 we map the word to unknown and skip gram model is given center word predict surrounding word in n-gram LM if perplexity if n increases what happens uh, you can divide it split it as in training case and in test phase probably it increase and for some corpus given uh, at the end there can be W which is added to indicate a word boundary sometimes and there was problem such as be it words and if we want to calculate it by using the MLE with unigram model, then we simplify the assumption by each its x is independent. We can find it easily. If biogram model, then we need to do some ph and och and h equals to p it multiplied by p och when we eat it and p and when we eat oats and oats and p 8 and we should get this probability and RNN vs transformer for RNN weights are shared or we can say identical and for transformer it needs positional encoding and for RNN it will be grow linearly and transformer it will be grow quadratically. And there was question regarding task dimensions. Now, there's question regarding dimensions. And a very important thing is we should understand the code. There was transformer building block code come out. And what we should do is really understand the code, which means in transformer, there is case that we should for batch and length, size, and dimension, we divide it and we make a key value. And there is part we make it when we making mask, except special 13 part, we make it minus infinity, that part. But here, the code is not remaining, which is that when layer goes deep, how should we do? This part was missing, so we should add that part. And there's also part uh, related with in context part, and scaling law, and heavy tail problem. And when there is heavy tail problem, then we can solve it by like sample p by p probability or n words. That could be also solution. Or and one interesting question that I had was when into instruction fine tuning, maybe can we change internal architecture of the model? That's one of the question. And maybe DPO by preference optimization, not using reward model was also interesting topic that you can remember. And for how to using transformers, what we should do is first getting a library, and based on it, we have low text, and we are using tokenizer. So model and models tokenizer are always go together. And in this case, we are bringing tokenizer, which is authorized tokenizer, which named Siebert sentiment. We can print model because it's based on torch and module. Torch module and module can see what happened when. So if you see the classifier, then here this is the backbone part, and we are doing sequencer classification. So there's another one for come here. Then after that we can make negative label and so on. So if you print out tokenized input will come out like this, and model output will come out like this. Then model can analyze the output. You can check it, check this model at Hugging Face and how to use it also this. And one more thing is, it's really important that we should know the background. Like CUDA, when you are not able to uh, run CUDA because of version issue, then you should think of how can we think of in underground. Then we can just compile it. Okay, that was the my what I do today. Thank you very much.